Hello folks, and welcome to the channel, or welcome back, and we're going to continue to work on the Ford SX V6, and more specific, the carburetor. The default carburetor on the Ford SX V6 is the Weber DGAS 38, and DGAS stands for Doppio Gu Acqua Sincroni. My Italian isn't all that good, but I'll explain you in a few seconds what this is all about. But that's where the name comes from, DGAS. In the past I've made several videos on Weber carburetors, and more specific the DCOE carburetors. And at that time I had a question about the DGAS. Well, now the time has come to talk about the DGAS. As we did with the DCOE carbs, we're going to talk about all the different elements that make up the carburetor. We're going to take it apart. We're going to look at all the circuits that make it work together. So we're going to start with idle, we will move to the progression, we then get to full throttle, we then get for normal cruising, and even the cold start. And if you're not sure about your carburetor, well, look on the side of it. It's typically behind one of those idle screws, and you have a stamp there and it says a 38, remember that's the opening, DGAS 38, so actually what it means is that you have twice a 38 carb here, DGAS. And if you wonder what DGAS actually means, well, D stands for Doppio, which means two. And this is actually two barrels, as you can see, two barrels that are going straight down through the carb. So that's the D. The G stands for GU, and GU means downdraft. So this carburetor is mounted on top of an intake manifold. It's not the side draft, it's a downdraft, so air gets sucked in from the top and then into the engine. And then finally we got the aqua. Now aqua is a bit weird because what has aqua, water, to see with the carburetor? Well, that has to see with the choke system, and here we have the choke system, but of course it's not installed. And typically on the TVRs you have your cooling system, the cooling water that runs through the side of the carburetor over here, and is an attachment to this that actually will then control the bimetal inside this box here, and then it will actually throttle the choke valves, or the throttle butterflies. They will open or less open, and that's the whole automatic choke system. Now many TVRs have that replaced with a manual system. I do have a manual system right here. This is the one that bolts on the side, but we'll talk about all this. And then finally we have the synchroni, which means synchronous, and that relates actually to those two toot wheels that you have here on the side. And if you're going to push the gas throttle, let me hold it like this, then you will see that will move, and both will move synchronously. So both valves in the bottom, if you can see that, will move open. These are the gas throttle valves, or the gas throttle butterflies. They move open in a synchronous way. So that's what it means. So now you know what that is all about. So now we're going to talk a little bit about all the different parts on this carburetor. And then we're going to look at another carburetor which is almost exactly the same, but not built in Italy. And that's this one right here. Now this is a brand new one that I got. And this is built in Spain. The original one that I have is built in Italy, and the quality is quite different, but we'll have a closer look, and there are some differences between the two as well. So if you decide not to recondition your old carburetor, which you can very easily do with a reconditioning kit, which I actually have, because I will recondition mine actually, you might want to go for a new one. But keep in mind that the new one will take some adjustment before you can put it on your car, if you wanted to have it to work the same way as the old one did. So maybe what we should do is now first look on the original Weber that is on the car, the one which is made in Italy, and then have a closer look at all the different components that are on there and what they are. And after that we'll compare the two with each other. The linkage coming from your gas pedal is picking up in this point right here, and that is going to open up or close the butterflies for the gas throttle, like so. Now this is pretty good quality, and your idle RPMs are adjusted right here. So this is where you would adjust this, and you can see how that is actually moving. If you look on the bottom, hopefully you can see it, and it's a bit tough to show it like this, but I'm going to try it anyway. If I open it up, you can see the butterflies that are opening up. This is what we call the butterflies. These are 78 degrees butterflies. That's the angle they are sitting in it. And the opening that you see right here, this is 38 millimeters. That's where the DGAS 38 name comes from. And if you look very closely, you will actually see a number stamp there, 27, 27. That is the venturi, or the yoke as we call it. It's a fixed yoke. You can't change that. Where on DCOE carbs, you can put different yokes in. Now this little tube right here, this is a vacuum tube. You have it on both sides, but in this car I didn't need it on both sides, so it's kind of blanked off. Of course, this is blanked off in the wrong way. It should be a lot shorter, but we'll correct that. So let's turn around the carburetor a little bit and then have a look what we see here. On the foot of the carburetor, which is mounted onto the intake manifold, you will find the idle mixture screw. There's one on each side, so one serves 3 cylinders on the Ford SX36. So with this screw you can enrich or reduce the mixture going into the intake manifold. And I got to be a little bit careful when I say enrich or make it leaner, because that's not what we do. This is only the volume of mixture that is going into the intake manifold. The actual mixture ratio is defined by this screw inside here. So if you take this screw out, you will actually see an opening for an air bleed and an opening for a fuel bleed. But we'll talk about these different channels later on once we get to that. And you can already see these channels running down here, how they will act up and how they will all work together once we are running idle. On the other side, of course, we have the same screw because the carburetor is actually a double carburetor. Now what you see here on the left, this is kind of a special item that you find on this specific carburetor. The Spanish carburetors don't have this. This is actually the anti-stall membrane, and it's a membrane with a spring inside. And if you follow that hose, you will actually see that this is actually coming out here in a, I don't know if you can see it, but there's a little hole there, and that's the vacuum which is going into that. And on this side we actually have the fuel feed. So the fuel feed comes in from the bottom and the return goes back on the top. And all the way on the bottom you see a big nut, and that nut contains a filter which is sitting inside, so a small fuel filter. These are all parts you want to replace once you overhaul the carburetor. And if you look on top of the carburetor cover, you will see that it's a Weber and made in Italy. If you don't have this one, it will probably say Weber made in Spain. But this whole part here, that's the carburetor top, which you can actually take off by undoing these bolts here. And then the whole thing actually lifts up, and then you can get access to the fuel chamber. And the fuel chamber is this whole area right here, and that of course is also holding the float inside. So the float is inside, and the needle valve, which is then blocking the fuel incoming if the float level is at the right level. And on this side we actually have the acceleration pump. This is the lever. If you depress the gas throttle, it will pump and it will push more fuel into the intake manifold through the carburetor, of course. And we will take this apart and we'll check the membrane on this. And then underneath you have a vacuum, which is typically go into your distributor. And on the bottom we have again, for the other side, the idle mixture screw. And this whole assembly right here is actually where you normally fit your choke system. So this is the bare choke system, and onto this area you can actually now fit either a water-cooled automatic choke or a manual choke. This is the membrane for the choke adjustment, so depending on the temperature and the position of the throttle, this membrane will actually move the butterflies for the choke more or less open or closed. And there's an adjustment here on the top. This is the little screw that you can adjust that one. I'm just going to try to show that to you on how that could work. So normally you give it a little bit of throttle and then you can actually move this. See that moving up here? So this is how that normally works. And on the bottom we've got the throttle butterflies that are opening up as soon as you open up the throttle, as you can see. And you can also see the mechanism that is leveraging the acceleration pump. So if you do it slowly, it's not going to inject a lot, but if you do it quick, then you get fuel injected through additional openings in the carburetor. You will see a lot of little holes all over this place. There's holes in there. So this is the idle mixture hole. There's acceleration holes further down, and I'll walk you through all this later on once we start talking about the circuits. But it's important to notice that you have all these holes and they all have a purpose. This is the top of the carburetor, and you see the two barrels. And I guess if you look closely, you see immediately something is missing here. We are missing actually the butterflies for the choke system. Somebody removed them. I don't know why, and some people believe that if you want to race the car, you have to take the choke system off. Well, I'm a non-believer of that, but okay, everybody has his own beliefs on this. But if you really believe that the choke system is causing some obstruction in the airflow, and it probably is causing some, other turbulence of air, then by all means, then remove the butterflies, but also remove the shaft or the spindle. It doesn't make sense to keep that spindle then. But I'm going to put these butterflies back because I want to have a choke on mine. Nevertheless, you can see some additional jets that will enrich the fuel depending on what circuit is active, and don't worry about it, we'll talk about it later. And if you look inside, you can actually see the Venturi. This is the Venturi right there. And the Venturi is 27. Remember that number on the side, 27? That is the Venturi size. Where the opening actually at the other side is 38 mil going to the intake manifold. That means that the air flowing in here will have to accelerate. So we get a faster acceleration. And that is why we get a great Venturi effect. And the Venturi effect is going to happen right underneath this metal piece here. So let's see if I can actually open up this a bit so you can see it a bit better. Now you can look through. So air will flow through, and then here we're going to get a Venturi effect. And this is about it on the outside on this carburetor. What I have on my right is the original Italian Weber 38 DGAS. On the left I have the Spanish version. Now, if you like to buy the Spanish version because you don't have a carburetor anymore, or you think your old one isn't worthwhile repairing it, I have one good advice. Overhaul your old one if it's an Italian Weber, because the quality is a lot better. I mean, the way it's been built, the way the finish is, the way axles fit together, the spindles fit together, and you'll see it in a few minutes, it is so much better. So it's worthwhile to rebuild your old one. But if you don't want to, then you can always use, of course, a Spanish Weber. I mean, they work fine, nothing wrong with it. It's just a bit less quality. However, you have to be careful because there are some differences. And by the way, the Spanish Weber runs you around 320 to 360 euros. Not a lot of money, but still enough money, I think. And you can actually do a complete overhaul of your old carburetor for around 70 euros. So I'm going for the overhaul of mine. But nevertheless, let's look at a comparison between the two. Now, at the first glance, they look pretty much the same on that side, don't they? The choke mechanism, and by the way, they're selling this new Weber under the context that it's used for racing. Well, we all know that is not really true, but okay, that's the sales argument, I think. What I have here is actually the mechanical part that fits on there for the choke system. As I said, you can either mount a water-cooled or water-driven system on it that will move this little pin around. And the same thing on this one, it's exactly the same. So you can do that. So you can mount this part. This one is for a cable, so you can mount it on this one or on that one. And don't worry, we'll talk about this later. So that's one thing. For the rest, on that side, it looks pretty much the same. You got the mixture screws. The openings are the same. So I already checked how you fix it to the intake manifold. That's the same. So there is not a lot of difference. We got the acceleration pump. Really not a big difference. So let's turn it around a little bit and see what we have on the other side. Now, here things come in a bit different. You can see actually that the whole linkage system is about the same. This one is bent, by the way. It arrived bent, so that tells you a lot. This one, my old one, is still straight. And I don't know if you can hear it, but I'm going to try, right? It's very flimsy. You can hear it here. Over here, there's a lot of play on that. Now, it's just the choke part, right? Now here, I don't have that. Listen carefully. And now this side. So you can already see that the machining isn't as accurate on the Spanish one. Also have a look on these Synchro Wheels. These are nicely aligned and there's even a mark on it. Here it's not. They are not even aligned. But okay, you can actually adjust the screw and then deal with it. However, if you look from the top on it, let's see if I can show you that. Yeah, let's do it like this maybe. I hope you can see this. See how much higher that is versus that one? So in other words, you only take half of the teeth on the tooth wheel I used, and of course that's not good. So that would have to be adjusted and corrected. I don't even know if you can. Now on the original one, look at that. And this guy had so much mileage already. It's flat. I'm using the complete tooth surface for this Synchro system. So that's a quality difference already. The next thing to look at is, let's turn it around a bit and then look at the next area. Here we go. So, wow. Here we have a difference. Look, we are missing something here, right? We are missing the anti-stall membrane. On this one, we've got an anti-stall membrane. Now, if you decide to install the anti-stall membrane from your old one on the new one, you can do this. But there are little holes there inside these. You will have to drill those out. But even more so, the connection here on the foot, where this hose is going to, is missing. There's a mark, so you have to drill that out, put a little tube inside, and then you connect things up. So that's a bit of work, a little bit of fiddling. I don't know why they haven't done that. I would have drilled it all out, prepared it, and then just put a stop on it, but I think they just went on the cheap. I'm sorry to say it like this, but that's how it looks like. All right, let's look on the other side. Now on this side, well, things look pretty similar. Acceleration pump. We already talked about the anti-stall membrane. But now the fuel intake, it looks quite a bit different. I'm having an intake on the bottom and a return on the top. Here I have only an intake. The other side is blocked, so there's no return. So you would have to fix a return mechanism. Yeah. So there are differences. So which doesn't mean it's not going to work. You don't need the anti-stall, and then you can fix that return line in another way. You can put a T up or something like this, and then a return valve, and that will do the job as well. But it's just, I don't know, it's just not right for me. That tells me a lot about the quality of the build. But luckily, and I'm really lucky about this, I have the butterflies here for the choke, which I'm actually missing on mine. But the reason I'm missing them is because somebody has taken them out before. So, you know, this is not a manufacturing thing. But let's have a look on the bottom of this Spanish carb. I'm just going to move my original one aside, and have a look. And what do you see here? Isn't that something? I have two spindles, two different colors, a black one and actually a steel-looking one. Why is it not the same? You know, I don't know. So what I'm trying to say is that the Spanish Weber is a cheap replacement. You can make it work. I'm sure it will work. I haven't looked at it inside. We'll see that. We'll do that later on to see how good or how bad it is. But my advice to you is, don't use this one. Try to rebuild your old one. And rebuilding your old one isn't very difficult because you can get all the parts for a reasonable price. If you do decide to get an overhaul kit, make sure you get a complete one. And it comes with different seals for the carburetor top cover. Order up also the power valve. That's important, and most of them are fitted with this. Some carburetors are not, but it's always good to add this on. This is quite expensive, actually. I think this is around 29 euros or 20 euros. You get the new idle screws adjustment. You got the little springs for it. You got the needle valve that comes with it. You got the membrane for the acceleration pump. You have the membrane for the anti-stall pump. all kind of little seals, copper seals, and we have basically everything. We have some seals for the foot, and it comes actually with a pretty nice breakout diagram on how all this is fit together. So all by all, this is worthwhile the effort, and it's not difficult, and that's what I'm going to do on mine, and you will see that once we start overhauling this carburetor. To take the cover off the carburetor, you only need to remove 6 screws, and they are fitted all around here. And I have them right here, so I already took them out. But before you can lift it, actually, you need to remove a little circlip which is holding the choke system. So it's over here, it's very small. So you're going to need a small screwdriver to remove this very little small circlip. Here it is. And that's also the reason why I'm working on a white plastic top, so I can see where all these parts are if I drop them, because I sometimes do drop it. So now I can lift this up and actually remove it. And here we go, and this is it. In the carburetor cover, you actually find the float, and this is the float, and the float has to have a certain weight, and we will double check all that. And to remove the float, you just need to push the pin out here on the side and then take it off from the other side very gently and remove it. And here we have the needle valve. That's the valve that will shut down the fuel as soon as the fuel level in the fuel boil is big enough, and this is the one. I'm just going to put it aside. And this is our power valve, and for that one we have a new one that we have in our kit, so we can install that later. So I'm going to leave it in for now because we're just looking at the different parts. This is the seal, so I'm going to take that one off. And then we have a couple of other things we need to look at. This is, of course, now the needle valve, and there's a number on that one, so we'll have to check all these numbers and see what they are. And I can see that the needle valve is a 250. I don't know if you can actually see the numbers, but I can see it. So I'm going to mark this down. And underneath this big nut, we should actually have the filter, the fuel filter. I already have it removed with a socket, and I think it's a 19. So you can remove it like so, but be careful with it. It's copper, or brass, I should say brass, right? Because copper is something else. Let me open that up. And here you have that filter, and you can see this one is having a bit of debris on it. So it's not all that clean, so it's about time that we worked on this actual carburetor. Let me see if I can take it out, and here that is. Here it is, you see the little pieces that are on it. So that's why it's so important to clean all that up. And now we can remove the power valve. I don't know if the membrane is broken or not on this one, but we'll find out soon enough. Here we go, that's the membrane. It still looked reasonably intact. Yeah. I don't think it's leaking, but we're going to replace it anyhow. So let's remove the remaining part of the needle valve. That should normally come with an aluminum washer here, but I see there's no washer on this one. That's a bit awkward. As you can see on the diagram, the needle valve, that's the one right here, that's the needle, and it should come with a little washer 13, and the washer itself should be a gasket for needle valve, and that seemed to be missing. And the new needle valve is a 250, and the old one is a 250, so we are good. So always make sure that you get the right ones if you want to stick to the baseline of your carburetor. Of course, if you're going to tune the carburetor, you may have to change those needle valves. So we're now looking at the base of the carburetor. So what you can see here are the auxiliary venturis, and you can take those out. And there is one side with a hole in it, and the other side doesn't have a hole. So keep that in mind, that the hole is always facing towards the emulsion tubes. That's where the main mixture comes in. And then it gets sucked in through this venturi, and there should be a hole right there in the middle. If you look all the way inside in that tube, you can see that. So let's put those aside, and then we can take the other parts out. Remember when we talked about the acceleration pump? Well, these are the acceleration jets, and there's one jet squirting inside one barrel, the other leg squirts in the other barrel, and this is actually the acceleration assembly valve. So we can take this out and put it aside. And there's supposed to be a small washer underneath. And if you can see it, but it's actually there, that small washer. And it has a size number on it, and I think it's a 55, so I'm going to mark that down. So far we have taken apart the top of the carburetor. Now we're going to take apart the bottom part and have a little chat about each and every component that we are going to take out. The next thing we're going to look at is to remove the emulsion tubes. Now the emulsion tubes are sitting on this side and on this side. So there's one emulsion tube per barrel. And on top of it, we actually have the air jet for the emulsion tube. And I already have loosened them up a bit before. And again, these little jets have actually a number on them. So we're going to mark those down as well, because that's important, as I said before, for the actual calibration or the baseline of the carburetor. Now inside we have the emulsion tubes, and they can be a little bit more hard to get out. So let's see if we can get them out. There we go. So this is the emulsion tube. And don't worry, we'll talk about those later in great detail what they do. But in essence, what they do is creating an emulsion of air and fuel. So an emulsion, as you know, is a mixture whereby the two parts are still very well visible, so it's not a very fine mixture. Okay. And over here we have the fuel well, where actually the float is sitting in, and where all the fuel sits for the carburetor. In the bottom we have the main jets. There's a main jet for each barrel, and there is the power valve. So let's take the main jets out and see what they are, and again they will have a number, and they are responsible for feeding the emulsion tube with fuel. And here we have that again, and that's a small number, so we'll figure that out what that is, and we'll mark it on our sheet, so at the end we can actually list all that up and then see how this carburetor is built. And now we have the bigger valve on the bottom. This is the power valve that is used to enrich the fuel into the carburetor during acceleration or low vacuum, when the vacuum drops all in a sudden on the intake manifold, because we are going wide open. And here is that valve, and that one we will have to check as well. And there should be a washer in the bottom. There we go, that's the washer. And on the side here we have a little screw, and this is actually the bleed needle. So the acceleration pump will produce X amount of volume to be pushed towards the acceleration jets, and some of it can be adjusted and some of it needs to flow back into the fuel well, and this is why we're having this needle in there. And we have a blocked off part, and inside you actually find a little ball that is going to be acting as the return valve for the acceleration pump. At the bottom of the fuel well, you will see a little hole on the left. Now that hole right there is actually used by the acceleration pump. So whenever the pump is activated, the fuel will be pushed out to the acceleration jet. However, to regulate the volume of that, how much is being pushed out, we have that needle that fits in here, and that restricts the bleeding of that acceleration pump through that hole. The other side, that's the intake to the acceleration pump, and that goes up inside a channel where we have a one-way valve, and that fills up actually the acceleration pump. And on the side of the carburetor we have our anti-stall valve, which is typically connected with the hose to the bottom side of the carburetor. So you just need to undo the 4 screws here, and there's a spring inside, so you might want to hold it a little bit. So I think this is now loose, so now we can take almost this off. Right, there we go. And here you can actually see the spring that is pushing this membrane. And let's see if we can take the membrane off. Oh, there's still some fuel coming out. Here we go. And that's the membrane. And on the side we have our idle mixture adjustment screw, only used for adjusting the mixture that is going into the engine when it's running on idle. And we're going to take these out, and there's one on the left and there's one on the right. That's one of the screws that you need to replace once you do an overhaul, because the tip tends to be damaged after a while. And the idle mixture screw is actually a needle that goes into that little hole right there. And the more you turn it in, the more you close the hole, the less mixture is getting into the actual cylinder. If you turn it outwards, so counterclockwise, then you're going to get more mixture into the cylinders of the car. So we can actually remove this guy. And per barrel, we have what we call the idle jet. And I need to open this. And now this is a bit confusing, the idle jet, because it's a combination of an air and fuel jet, and it will regulate the mixture air and fuel that you're going to use for your idle. So this works in very close cooperation with the idle adjustment screw. And here it is. You can see that little hole right there, and there's a little hole there. And actually, in fact, you can even take this apart. See, this is how it takes apart, and this is the actual jet. One opening for the fuel, one opening for the air. But we'll be talking about this very shortly. And there should be a little seal there. See that? That's the one we want to get out and replace. And of course we have a similar one on the other side, which is sitting a little bit higher up right there. And finally we can take off the acceleration pump, which is on the side of the fuel well. Just 4 screws to undo. So we can take this off. Again, you can see the membrane inside. Important that it isn't ruptured or there's no holes in it. And of course we also have the spring that goes inside, so these things will remove and get it all cleaned. And if you look closely into the acceleration pump housing, you can actually see this hole right here, and that is leading into the carburetor. That is actually going out to the acceleration jets, and the 2 holes that you see here, that's one hole is where the needle fits in from the top, and the other hole is where the little metal ball is, the little valve on how we're going to fill up this cavity here. And the last part is to remove the automatic choke. That's just to unbolt 1, 2, 3 screws or bolts, and then the whole thing takes off. There we go. There's still a few little things to take apart on the carburetor if you have to take it apart, and that's the spindles with the butterflies on for the throttle, of course, and also the same thing happens on the top of the carburetor where the butterflies for the choke gears. You can remove the spindles if you want. I don't need to remove the spindles right now. They're still intact. There's no reason to replace them. But if they were faulty or they were not all that good or the bearings would be gone, then I would replace it. So now it's time to start cleaning up the bare carburetor block here, and also the top part, which is already in the ultrasonic cleaner. And once that is all cleaned up, we're going to put it all back together and explain all the different circuits on how they work. And when we put it back together, we'll be using the revision kit that we already showed you before. But what is important when you take this apart is that you lay everything out pretty much in order. So you have a very smooth and clean surface, and I'm using kind of a plastic thick sheet here. It's clean because cleanness is very important when you're going to work on carburetors. And you can actually see where all the different parts are and how they fit together. If you don't remember how it was put together, take pictures or even tape it like I've done here, and that will help you to put it back together. But now we need to do something very important, and this is what we call baselining the carburetor. When the carburetor was built and set up for the Ford SX V6, it was fitted with the proper jets. And you've seen how many jets we have. You can see all the main jets, the Emulsion Tubes, we have the idle jet, we have the power valve, all different things. And even we have the valve needle. All these things now, we need to find out what the numbers are. And we're going to write this down on a piece of paper, because all these individual parts have a number on it, referring to the opening or the size. And that's what we now need to write down. And I'm going to do this on the board, and then you will see what the baseline is on this. It's very important. And you can check this baseline with the standard when the carb was initially built for your car. You can find this online, and I'm going to double check this on mine. I know more or less what the baseline is, but it's important to understand the full baseline. That's the right starting point if you ever want to start tuning your carburetor. If you don't do this, then and you start with a bad baseline, you can never start tuning. So you have to start from a reasonable working carburetor, and from there on, you start then tuning the carburetor by changing the different jets. And we'll talk about this once we put it all back together. So let's have a look on what the baseline is on this carb. The baseline for a DGAS 38 for Ford SX V6 is listed on the board here. The first one is the auxiliary venturi. This is actually the auxiliary venturi, and you've seen me taking that apart. And if you look closely, there is a number on it, and the number says on this one it's a 4, and it's supposed to be a 4 millimeter. The second one is the main jet, and remember the main jet is inside the fuel well. We took that out, and at the time when we took it out, we actually did check it, and it was a 1.45 millimeter jet. The air correction jet, that is sitting on top of the emulsion tube, and that is a 1.75 millimeter. The emulsion tube itself, we looked at the emulsion tube, and that was actually an F50. The idle jet, that is the jet that's sitting on top of the idle circuit, that is actually a 0.50 mil. And then the pump jet is a 0.60 jet. And then finally, the needle valve is a 2.5 millimeter needle valve. And the needle valve, of course, is the valve that allows fuel into the carburetor. So these are the settings, or the kind of jets that you should find back, and emulsion tubes that you should find back in your carburetor. And this is the base setting, or the baseline. So if you have that in your carburetor, that is a very good starting point to start tuning or correcting things. Always start from this point. It's so important. So folks, we are nearing the end of this video, and we have been looking at all the different components that make up the Weber carburetor. We've given a little bit of explanations. We took it completely apart. We have looked quickly at a overhaul kit, and we did compare the Italian Weber with the Spanish Weber. Apparently there's also a Chinese version of the Spanish Weber. I looked it up on the internet. It looks very much the same like a Spanish one, so incomplete compared to the Italian Weber. But now I'm going to get the whole carburetor cleaned up. All the parts will be cleaned up. I'm going to put it in ultrasonic bath, all the different elements, a little bit by little bit, because I don't want to lose pieces. And then we're going to put it all back together in the next video. And in the next video, we're going to talk about all the different circuits and how they work inside this DGAS Weber carburetor. And then we're going to assemble it all together, and then we'll mount it on the car and see how it goes. And in fact, I will be mounting also the Spanish Weber and the Italian Weber separately to see what the difference is on the TVR Ford SX V6. Thank you for viewing, and I'll see you in my next video. Thank you, and bye-bye.